Hi, this is part 2 of our weather station prank. In this part we will investigate how RTL433 gets data from that captured signal, how it decodes bits. These are tools that we'll use, RTL433 and Arduino. Here are some useful links. And agenda for today is examine electro.c and try to reproduce that signal with Arduino and send it to serial monitor, and result should be to get something like this. So correct temperature and correct humidity calculated from bits that we will fed to Arduino. But first I would like to make a note on one mistake in part 1. If you remember, we captured the signal with GQRX, save it to file and then examine it with Audacity and interpret bits out of it. And there I made a mistake at 6 minutes and 59 seconds in the video, where I misinterpreted one of the bits. So instead of 1 I interpreted it like 0. So the correct string was this, and the string that we get from RTL43 was this. And of course there is only one bit has been changed, and we'll also take a look what this means. Also because of there was one bit change, also the checksum wasn't exact, because this checksum is calculated from all previous bits. So just to note it, and we will also show today what it means if we change this one. We'll see. So let's go to part 2 and let's look at electro.c code. If you remember, when we fire up RTL433 and wait a little, so it gets data from a remote sensor, we get something like this. So electro version 1 temperature sensor with this data, and if you grep for this string in the RTL43 source code, it gets you to electro.c. and here in the header, or in the file, here you have documentation. So we are temperature and humidity type of sensor, not the one I used doesn't report anything for rain or wind speed, so this one is in our interest. And here it's explained exactly what certain bytes or nibbles mean. So if we go down there and find that electro version 1 temperature sensor, we get to here. So this is what it spills out when we run it. And of course we won't go through the whole code and examine it line by line. I would just like to point out how things work and how you can teach yourself out of this. So for instance, let's look here for humidity. This is the simplest one. Humidity is returns value from humidity variable, which is calculated here. So humidity is BCD decoded from reverse byte third one. let's just explain what this means. BB13. BB is an array of bytes and of these bytes. So first parameter is row 0, row 1, row 2, row 3, and the second parameter is byte. So byte 0, byte 1, byte 2, byte 3. So if we look at our case, BB13 means this one. So 13 is second line, fourth byte. So from this humidity is calculated. And one more note. So how is it calculated? First, it takes this byte and reverse it. So takes this one and reverse it. So if we reverse it, you get something like this. Reverse means just read it from right to left and write it down from left to right. So 0 1 0 1 0 1 0 1 1 0 1 1 0 0 1 1 0. That is our reverse byte. And humidity is as it's stated in documentation. Humidity is BCD encoded value, which means that each decimal number is represented by one nibble. So this first one gives us 5 and the second one gives us 6. And the formula behind this is reverse this one and BCD decode it. And BCD decode is another function which is located here, which tells us take the upper part of byte and multiply it by 10 and add to it the lower part. So this means 5 times 10 plus 6, and of course that's 56%, which is correct. And in the same manner, all the other values are calculated in this. So this is for humidity. This is part of code for temperature. One important thing here also is checksum. For checksum we have code here, and because this is open source tool RTL43 and it's written in C, we can just take it and use it in our Arduino sketch, and I will show you how this is done. So you should really examine this code. It's I thought a lot of out of it. I was really wondering what this BB means, and after some googling now I'm able to interpret things like this, and I feel fine. Okay, so this is our decoded string from last time. Let's use this one, which we read from RTL423, which reported 7.8 degrees Celsius and 56% humidity. If I will first show you that it's working, and then we will go through the Arduino code. So we must feed our Arduino with this data without that checksum, because checksum gets calculated. And if we look at our Arduino code, so this is our capture data. See, this for these values is this string, so also without the checksum. And if we put this data here, so this is 4 bytes, and use functions from electo.c file, we can get something like this. So anytime I press a button or my this little circuit with the Arduino, it gets this data and calculates humidity, temperature, checksum, and reports us the whole string. And this string is the same as this one, so it should be okay, right? Okay, so let's go through the Arduino sketch. I'm using this button. Let me first go to GitHub where I save all this, and let's look at this little sketch. Whoa. Okay, here it is. So in a simple manner, our Arduino, we have a switch here, because only when I press it, it starts calculate things and speed into the serial monitor. Think of now this transmitter and antenna part. This is a full circuit for later, when we will reproduce it and send the coded signal to our weather station. For now, we will just speed this to our serial monitor. So there's a button on pin 2, and the initial state is off or 0. This is our input data. This is this one, and in setup we just define that button is input, and we initiate serial monitor. And here are helper functions. These are exact copy-pasted functions from electo.c code. So we use this one, reverse. If you remember, this is just function to reverse bits, so why not use it? And this is procedure to calculate and speed out humidity and temperature, exactly the same code that is in electo.c. And here we also calculate checksum based on data that is fed to Arduino. Again, this is copy paste from electo.c, and here we just put that string together. You can just when you can just add together those bytes, because you're missing leading zeros. So I didn't find any better way just to go through it and add these leading zeros if they are needed. And we spit it out to our serial monitor, and that's it. So again, if I press button, we have this data, and if we change, that was in our 4th bit, right? Let me check which one was changed last time. This one, so this is correct one, and we had 0, 1, 0. Let's change it. So 0, 1, 0 in the last byte. If we change this and upload it to Arduino and check it now. Whoa. Okay. So no, wait. I have just replaced the 4th. Oh yeah, okay. Yeah, that's okay. So it has to be humidity changed, but could it change from fixed 56 to 52? No, I don't think so. I'm stupid. This one was changed in the 2nd byte. So let's fix it back to this, and in 2nd byte it was changed last forward all ones. If we change this one, the 2nd nibble all ones, upload it again to Arduino and check it. Here, see, there's only 0.1 degrees Celsius difference, because when we captured the signal it was 0.1 degree hotter outside than after when we get it from RTL43. So we're all good. If we leave this, it's here. So it works. And for part 3, where I will show you how I decoded this string, which means 9.2 degrees and 84% humidity. I use this data and send it to the transmitter to the weather station, and of course it showed this data. So yeah, it's working. So let me just fill this in. And check if it's working here. Let's upload this to Arduino. Done. Test it. 84%, 9.2. So that's it. In the 3rd part I will show you how I send this data to the weather station and it just worked. And I will explain some tricks and tips also in the 3rd part. So that's all for today. If you have questions, comments, post them below the video on YouTube. Bye.